Hi, this is my design and manufacturing project number 3. My name is Charlotte Meyers, and this is for Georgia Tech ME 3210 Design and Manufacturing for Fall 2024, and this project was submitted to Dr. Rashidi. For this project, we were given the prompt to go over 5 tools, techniques, models, processes that have been addressed in the class or in the textbook that appeal the most to me, explain what they are, why they're important, and then go on the capabilities and limitations of each of them. So for my project, I've selected these 5 to talk about, starting with sustainable manufacturing, then lean manufacturing, design for assembly, thread and gear rolling, and then surface treatment. To get started, the first topic that I chose to talk about is sustainable manufacturing. Sustainable manufacturing basically goes over the manufacturing process and just tries to find ways to make it more sustainable, more environmentally cautious. So I have written here that every year, 22.5 million metric tons of plastic waste are discarded. This is a quote from the textbook, and it goes to show the severity and the importance and the need for sustainable manufacturing. Beyond this, there's various byproducts that happen because of manufacturing. So this includes effects on the air, the water pollution, acid rain, ozone depletion, hazardous waste, and global warming. So keeping this in mind when we design parts or have in mind manufacturing processes that are sustainable and impact our environment are very, very huge. And then sustainable manufacturing includes some of these things like recyclable materials, reducing these hazardous byproducts and effects, and then waste disposal and handling. So overall, you can see why it is so important, and then also what all plays into different aspects of sustainable manufacturing. But sustainable manufacturing in itself is just making decisions for manufacturing that reduces the environmental deficits that it causes. I touched on this a little bit, but to go over it some more, the importance of it can make a huge impact on the adverse effects that manufacturing has on the environment. Of the 76.6 US emissions driven by the manufacturing process, 17% of that is directly from the manufacturing sector. It's no secret that we have global warming happening, and there's a lot of adverse environmental things happening. So keeping in mind all of this is really important. And then engineers have a responsibility to always consider the effects of their work. This goes beyond building safer and sturdier bridges, but also ensure that the work that we're doing doesn't harm the environment around us. So that's why I think this is super important, and it was the first topic that I wanted to talk about. The capabilities of it is decreasing the waste and byproducts and a positive environmental impact. And then the limitations is that it does make manufacturing more costly, and not everything has a sustainable option. So there's always that like back and forth of weighing the options, if there are options, and what they are. The next topic I choose to talk about is lean manufacturing. This is a subset of manufacturing that focus on the assessment of each activity, regardless of the effectiveness of its operations, the efficiency of the machinery, the number of personnel, the overall just the analysis of what happens in the manufacturing process. And the whole goal of lean manufacturing is to make it as productive and as efficient as possible and reduce waste, which kind of goes hand in hand with the sustainable manufacturing that I just talked about. So lean manufacturing also works to optimize the customer value by decreasing any of the waste and increasing the efficiency of the manufacturing line. It's really important because it aims to make manufacturing more efficient, allowing engineers to provide a better value to the customer. Again, reduces the waste, so it's sustainable. It allows us to focus on productivity. For example, if we have an assembly line, making sure that the product gets touched or moved as little as possible. Little things like that can really make a huge difference in how fast the product gets to, and then it makes it cheaper for the customer, and then the customer is happier. And it also lays the groundwork for automated or lights out manufacturing, just kind of looking at things from a perspective of how can we make this more efficient and how can we do it to the best of our abilities. I thought that this was really important because although lean manufacturing isn't striving for perfection, it means that there's always a better way to do things than we are doing it. And I think that's really important just for engineers to keep in mind that there's always a better way and there's always a more effective way to do things, and we can continue to work towards that. It improves productivity, it decreases time and cost, and it maximizes the customer value. The only difficulties is that it does require that out-of-the-box thinking, so it may be a little bit difficult to implement, and it takes some time to think about in order to implement. The third thing that I wanted to talk about was design for assembly. Design for assembly is an offshoot of the concept of design for X, meaning designing with a certain goal in mind. Design for assembly or disassembly is overall, we're trying to design with the idea of putting it together as fast and as effective as possible. So it can reduce the amount of fasteners needed, reducing the cost, reducing the amount of time that someone's spending on it. Again, all of these things that I previously talked about in terms of just making things efficient and better. Design for assembly also allows the customer to have a better interaction with the product. So being able to assemble it or disassemble it at home and being able to do home servicing. And I included a little picture here. This was from the video that we were shown in lecture of a printer that was able to be put together in a mere couple of minutes as opposed to its predecessor that took much, much longer. So you can just see how much simpler things are. And it really is an attest to the engineering that went behind it, having to think about how can we creatively come up with ways to self-align things or put them together. It's a whole new engineering challenge in itself. So the importance of it is it's an incredible practice, regardless of what the X that you're designing for is. It kind of creates this new way to look at the problem. It comes up with a new, intentional design, so to speak. And you can come up with some crazy innovative solutions just by tackling the problem from a different way. Instead of thinking, how am I going to make this product? How am I going to make this product do exactly this? Can kind of lead to a bunch of different open doors of ideas. It improves customer value, decreases the cost. And it kind of adds this little excitement product to the product. So although you get a printer and it prints, you would expect that to happen. That's, something that's expected and normal. But a printer that you can at home fix, take apart, and put back together really easily adds to that excitement to the customer. It's innovative, it decreases the time and cost, and it maximizes customer value. The limitations is that it does create an extra level of difficulty in the design process because there's more considerations going on. How can I decrease fasteners? How can I make things align? But if you look at it the other way, this is, food for thought. It's a little bit of a challenge for engineers. Next thing I wanted to talk about was gear and thread rolling. So thread rolling is a cold working process where a machine blank is compressed between rotating reciprocal dies. So this is kind of how they take a stock piece and they roll threads on it so that it can be used as like a big screw. It creates these external threads. And if you look at the image on the bottom here from the textbook, these threads that are created through thread rolling are a lot stronger than those that from machined. This is important because fasteners that have these kinds of threads on them are required for everything. This process is very precise and fast. If treads or these little grooves are not perfectly aligned, it will cause faulty parts. So this has to be something that's done with incredible precision. And the production rate in thread rolling is as high as 30 pieces per second. So it's a big attest to what we're capable of doing. And then, like I mentioned on the previous page, the thread rolling process produces a higher strength without the loss of metal. So again, hitting on the sustainable manufacturing, we're limiting the waste going on here. And there's a wide variety of applications. Cold rolling has a ton of different usages outside of just fasteners and automatic transition and power tools. So it creates stronger threads and it minimizes waste. The limitations are that for thread rolling, sometimes you have to have a specific length and diameter, and opposed to other processes, it may end up being a little bit more costly. And finally, the last thing that I wanted to talk about was just the general surface treatment process. Surface treatment encompasses a whole lot of different things that can be done to the exterior or interior of a part for appearance or performance reasons. Several mechanical, thermal, electrical things can play into this and improve the tribology of it. And then the surface treatment can affect the surface integrity, the surface roughness, the friction, the wear on it. So all of this just goes to show that surface treatment is this big overlapping process that talks about the material surfaces and how we can improve it for performance, durability, or appearance. This is really important because understanding the desired properties or functionalities of a part can have a significant impact in the overall product and the view of it from the customer. Although it seems like such a minute and simple thing, being able to make the product look good, or maybe you have something that you don't want to pick up fingerprints, choosing a surface that doesn't do that can add that excitement to the customer. And then in my experience, my limited engineering experience, surface properties and tribology have come into play on a lot of different projects, where it may have been something that was sacrificed for another piece of the project, and it's ultimately ended up ruining the functionality of the piece or not having the piece perform or look the way that we want. So it's definitely really, really important, and keeping it in mind when designing can totally make a worlds of a difference from what I've seen. It increases the customer value and satisfaction, and it impacts the effectiveness of the part to do its functionality. The only limitations are that not all properties can be manipulated, and that this adds time to the manufacturing process. And that's all for my presentation. Thank you so much. And this page goes through all of the resources that I used to compile this information, as well as all of the pictures and videos included in this.